One, how are you? We are back. Not quite from the hiatus of the holidays yet, but welcome to the Physicist and Philosopher Hour, the year in review, and
Uh-huh.
our physicist is Dr.
Hello.
Albers, the one and only, and the philosopher is myself. And I look at myself, Claudia, as I. So there we go. So, Claudia, how are you? We weren't on last week because it was Christmas Eve.
hmm
We're going to do a shortened version today, but tell me, how was your Christmas? How has the holidays been?
You know what I liked the most about it was that it was quiet and I managed to get some extra rest.
Good, good.
And I got some very nice presents from Scott. He bought me some nice presents. And
Well, that's because, the
yeah,
man digs you, as we used to say. He really digs
it was
you.
nice of him. It surprised me. I told him I don't want anything. I don't want anything, but he gave me a whole lot of stuff.
Oh, he's a good man.
Mm.
Just, stating the obvious, right?
Yeah.
So you got a little bit of rest, and which is good. I always say to you, because you do have this propensity for writing, endless writing. So it's often
Yeah.
wonder, when do you sleep? Rarely?
Oh, I need to sleep. I actually sleep quite a lot, but I usually like to finish what I'm working on. So sometimes I go to sleep very late because of that.
Mm-hmm.
And then I end up sleeping a little bit longer than I'd like. And so it becomes a pattern that I don't like. I'd rather wake up earlier but I just cannot leave it alone. I have to finish this.
Oh, well, that's how those
Yeah.
things work, no doubt. I love that. It is like, well, I want to get this done. Well, listen, I was the same way. Now, I've been reading a book, and it was 300 and I don't know 75 pages, and I consumed it in a day and a half.
Wow.
And but like when you really get into something and your mind begins to fixate and focus in on it, yeah. And as far as my sleep patterns, I need at least 6 hours of solid sleep.
Mm-hmm.
And then all my professional life, as a CEO and even coming up through the ranks, um, I'm a big believer in power naps.
Mm-hmm.
We taught that to our employees that, by taking 20 minutes in a day, sometime during the day, and literally get so relaxed, Claudia, where you sleep, you actually get into the beta and theta waves.
Mm-hmm.
Um, it's amazing. Now, for myself, it's like plugging back in and getting a full battery charge.
Yeah, unfortunately, that doesn't work for me
That way.
because my mind will work nonstop until I literally fall asleep. And if I try to close my eyes, all I can do is think about it. So it just
Hmm.
doesn't work.
Now, do you dream?
Pardon?
Do you dream?
Yes, I sometimes dream about what I've been working on.
Ah, interesting.
Yeah, my mind just doesn't stop until I've solved the problem.
Well,
So, or I fall asleep because I'm literally too tired to think anymore.
Claudia, and as I look back in, the corporate life I lived, I have a lot of friends that were attorneys and working to get partnerships in law firms. And they were doing that, working 80 to 100 hours a week. And I got a sense that that's what you do.
Yeah,
Yeah.
you see, I'm trying to work out things and problems that no one has ever worked out.
Yeah.
So
Yeah.
it takes a lot of thinking. I do need at least, I know even as a student, I needed 7 hours of sleep whenever I was into deep study,
Mm-hmm.
because otherwise my long-term memory doesn't keep hold of things. But I may look relaxed to other people, like I'm not thinking of anything, but my mind is turning. It's thinking
Sure.
about the latest problem.
Mhm. No, I think that's great. Philosophers do the same thing. We just look at things from a little different point of view.
Mhm.
It's constant. And I think for ourselves today, Claudia, as you and I were talking before we went live, um, I think 2018 was an interesting year. And I look at it from two perspectives. I think from a philosophical ideology point of humanity, we're seeing a continued migration, not one that I like. And for science, and this was just my take, I think 2018 was the year that we found out that our science was all wrong.
Yes, I think so.
Yeah.
I started finding that out years ago, but I always thought, no, that's fine. Now it turns out that just about everything is upside down. I mean, for instance, today I actually found concrete evidence that Jupiter is actually, because I've worked all these things out step by step, that Jupiter is a stellar core. It came into the solar system as a Planet X object. It absorbed material from the sun and then it went into orbit around the sun, but it's much further from the sun than Earth. And any object that is further than Earth has a lower gravitational potential than Earth.
Mm-hmm.
And it's an object that's 11 times the size of Earth. So it means that it's got a dead core. It's a dead planet.
Mm-hmm.
And all those gas giants were actually acquired from the Planet X system.
Is that by a binary star system that our star is with another star?
Now, the Planet X system is actually that cloud that encompasses the solar system, where there are thousands of these objects that are all dead. All the stars are dead, all
like
the planets.
Like the Magellanic Clouds?
Yeah, it's like the Oort cloud from which they say all the comets come from. But that's what the comets are. There are all these objects that are dead objects are coming from there. And that's where Jupiter came from.
Well,
probably a couple of thousand years ago, because it's been there for a while now.
Yeah. I often wondered about Jupiter, Neptune, particularly, and even Saturn now. But you have the Jupiter comet field, very distinct. Then you have the Neptunian comet field, where you have comets that are in a orbit around them. So, all right, so help me on this one, Claudia.
So these what they call comets are actually the debris fields.
The debris fields, yeah.
Of the objects that are coming in. And what happens is they come into a solar system object, and I have figured out as well that all solar system objects that have living cores are capable of mass creation.
Okay.
So whenever the Earth has a volcanic eruption, it's the same as a CME. It's actually a matter creation event that occurs at the surface of the core. And it creates matter in the form of this liquid plasma, which we call magma. And then it erupts. And that's why we get volcanic eruptions.
Well, so let me ask you, why doesn't Earth have a debris field?
Well, Earth is being engulfed in a debris field. It's constantly coming into our atmosphere.
Okay, so when I look at what we have, what we were discussing, these comets, the debris fields around these individual planets, it would only make sense to me that we should see the same thing with Earth.
And we do, because that's why we have objects that are narrowly missing Earth all the time. Plus, we have all the dust coming in all the time. And the dust is actually what causes I mean, we have pink clouds all the time. We have fog all the time. And I figured out that it's what causes rain on our planet. It's the planet X system dust. Without them, there would be no rain. Because what happens is they enter into the atmosphere. They then attract water from the atmosphere. They absorb energy from the water. And that's what causes the water to eventually condense. And then as it absorbs energy, it gathers enough energy to drop down to the surface. Because in the beginning, it doesn't. It's in the atmosphere because it's low gravitational potential material. So it remains suspended in the atmosphere until it's absorbed enough energy from light, from water molecules, and then eventually it absorbs enough. And just before it gets to that maximum amount of absorption, what happens is the clouds turn gray. And then it's got enough energy and it falls down towards the surface. That's what causes rain. This is what happened at the Great Flood. The Great Flood was when it started raining on this planet, because that's when the planet X system started affecting this planet.
Interesting. You know, I did a video.
I've written a whole lot. I'm sure you haven't had time, but I've written a whole lot of articles. Yeah. I've been thinking about this. And the latest one is about Jupiter and the gas giants. Mars is a living planet, and it was affected quite a lot like Earth was, because it has volcanoes on it. And I think there's signs that it actually expanded. The Earth has definitely expanded to nearly twice its size that it had initially before the flood.
And just thinking about that, then what we would also see then would be, well, you would see global changes. One of the things I was immediately thinking of was barometric pressures. As a planet, I think as it would expand, maybe I'm wrong, but you would begin to see a lessening, I would think, of barometric pressures as much more condensed. Am I wrong on that?
Well, what happened was the surface gravitational acceleration increased because now there's more mass. And even though the surface moved further up, there was still an increase in gravitational acceleration at the surface. So that means that all the animals suddenly felt heavier. So what did that do? That caused animals to become smaller. And we have evidence of that. We have that giant sloths that were the size of elephants. And these lived up to 4,200 years ago. We have the saber-toothed tiger that is much larger than current tigers. There were camels that were 12 feet high.
Yeah, you know, it's interesting. I did a video last week on cataclysmic geology and reading the debate in geology between cataclysmic theory and what they call utilitarianism. And where utilitarianism says that geology is a very slow process, where cataclysmic geology says, no, that's wrong, that the Earth has ample record geologically of sudden cataclysmic change. And as you were mentioning about the saber-tooth, you know, did a whole study on, you know, the woolly mammoths having food in their mouths, flash frozen.
Yes.
So cataclysmic changes on the planet. And apparently our planet is a very volatile planet.
Yeah, it is because of the planet X system that I think started affecting our planet about between 5,000 and 4,000 years ago. That's when a whole lot of these objects started coming into the solar system. That's when a huge comet came to the Earth. And it caused all these volcanoes to erupt, to form. when it came to the Earth, because it must have been a very large core, and it caused the Earth to create a lot of matter. And they do that through the electric field. And it wasn't just that. So the Earth started growing. Plus, this object must have been, when it was a living object, it must have been a large planet with a large ocean. So there was a lot of ice, debris around it. So what happened was, when it entered the Earth's atmosphere, so did the debris. And a lot of this debris was in the form of ice blocks. So guess what happened? A lot of these ice blocks fell on certain areas, perhaps where these animals were. That's why they died suddenly and were flash frozen.
Yeah, and the thing about it is that we found evidence of that not only in North America, Siberia, Asia. We found evidence of it as well in areas near what we call equatorial regions. So whatever happened, it with a sudden violence form. In fact, I read to my audience, Claudia, a CIA document where the CIA was doing extensive studying in this sudden cataclysmic geology change. So, and as you talk about the Planet X system, we know planetary objects are affected by other objects. It's like billiards. I mean, you bring in one object, it's going to have a cause and effect item on these other objects. Yeah,
because as far as I figured out one thing as well, I mean, I figured out so many things. And one of them is that, they say that there is desiccated blood in chemtrails. And I realized one thing. I mean, if they put in these kinds of diseases and blood in chemtrails, the people responsible for it would be exposing themselves to it themselves. So after I thought about it, I realized that the desiccated blood is most likely not coming from the chemtrails, because now we know we have huge amounts of Planet X dust coming into the atmosphere. So the desiccated blood is coming with the debris. It's not coming from the chemtrails. The chemtrails is a way of hiding what's really going on. And this is why we have in some of the historical record, things like rivers turning to blood. They were actually turning to blood because there was blood coming through the atmosphere. And that's why people in the olden days were so afraid of comets and said that they brought disease. They did, because there were animal remains in the debris. And what does that show? That shows that the planets exploded. They broke apart. They didn't slowly die. They suddenly died. The outer layer suddenly exploded outwards. All the animals on those planets died, and their remains remained with the debris. And this debris is coming into our atmosphere. And then they say, they don't mind us believing that it's with the chemtrails. I don't think they even mind us knowing about chemtrails. I mean, they pretend they don't want to, but what they don't really want us to know is about the Planet X system and what it's really doing to our planet and where it comes from.
Well, I hadn't heard that, so that's new. And we're talking. Go ahead.
Sorry, and I just wanted to say they come in as a system because they suddenly die. They would stay together, the star and the planets. But they would stay the same because their ratio gravitational potential would stay the same to each other. But the star now has low energy, and if it's orbiting something that has the same amount of energy as before, it would tend to move. And then it would probably move into the solar system, but it would move together. It's a star with each planet, and each of them with a debris field full of pieces of rock an atmosphere, and ice, and dust. And then they would go to, well, the larger ones go to the sun, because I found out they can only absorb matter from objects that have a comparable amount of energy, or material with a comparable amount of energy. I call it gravitational tuning. And so the larger ones would go to the sun. The smaller ones that are planets will go to whichever object in the solar system is of comparable energy. So they would go around and make of the solar systems they host. And then what they do is they absorb matter. They cause the matter creation event from the core of that object. They absorb that as a layer. They deposit their debris in the atmosphere of that object. And then eventually they settle in an orbit, which would be associated with their gravitational energy in the solar system.
Well, that would bring a lot of change, I think, on a planet. I don't know, just from a, looking at the ecology of a planet.
Yeah, I mean, our planet has been affected by the system since the Great Flood. It has never stopped. I mean, it went through a huge cataclysm. It changed the planet completely, which then changed the animals and the plant life on it, but it never stopped because these objects never left. And most likely the host object, the object that made Earth its host, is most likely still around. I don't know if it went into orbit around the sun or if it went into orbit around the Earth, but it would still be in the solar system. They don't leave.
Well, this is very interesting because when I look at what I'm observing in mainstream science, by the release of papers, peer review papers, and there is a shift taking place. I think Harvard was the first one to admit black matter doesn't exist, that it's a plasma universe, which I think is just the next step to electric universe. Now what we saw with Oumuamua, where it was acknowledged that this was an interstellar object, again, quoting Harvard, it now appears, the discovery is, that there may be, in fact, 1,000 of these objects that have now entered into our solar system. Are these connected, do you think? Do you think they, because these are interstellar, they're not from our solar system, our region?
Well, all the Planet X objects are not from our solar system. They come from outside. And I mean, the evidence is that our solar system is just so full of material that came with these objects. The cores themselves that were once living stars and planets, and the debris fields that come with them, huge rocks.
Well, they said the thing with Uranus is that an object 4.5 times the size of Uranus came by and knocked it on its side. And I when I read that last week, I thought of you immediately, and I'm thinking, well, this is a very unusual admission. A big rock, exactly what they said too, Claudia, a big rock. And I went, well, how freaking big is the rock?
That's possible. Don't forget that Uranus was once a stellar core. It probably one of the initial ones that came in and is now in orbit around the sun. So it has a dead core. So I don't think these objects would be attracted to it as a host body because it cannot create matter. But they can still go by and do some damage to it, I suppose.
Well, I mean, it turned it on its side.
Yeah, that's a possibility.
And what's so weird is that not only did it knock it on its side, the anomaly that I still kind of scratch my head about is, well, the poles, the magnetic poles, they went on the side. They did. It's so weird how the planet is. So I it's one of those that I'm going, okay. And then Jupiter. So I was reading. Go ahead. Good.
Now, Jupiter is our largest planet, but so far out in the solar system, as I said, I mean, it would have a core because, the Earth now has a core that's 20% the size of our planet. But the Earth has increased in size. So the original size of the core was 40% of the size of our planet. So we don't actually know enough about the other planets to know anything about it. You need actually to do seismological studies to find that out. So using that, you would expect Jupiter to have a core that's 40% the size of the planet, in which case it would be 22 times larger than the Earth's core. So if it was a living planet, it would be in the inner solar system very close to the sun. And it's not. It would be in the inner solar system because it has a much larger gravitational potential than the Earth. And it's not. So it's a dead object. And then the other thing was that, remember that we kept seeing that ejection from supposedly Venus. And I used to always say, but it's impossible because Venus is a planet. Well, as it turns out, I've just discovered that stars and planets are the same thing. I call them white holes. They create matter. So it's possible that if there is a stellar core that is very powerful, about the same energy as the Venus core, it would be able to cause Venus to do matter creation events, and then it could eject plasma like that.
Well, I contend that Venus is a comet, so that's
my
research has shown. So I could be wrong.
I'm not sure about that because Venus is smaller than Earth, and it's in the inner solar system, and it seems to be volcanically active, which would mean that it has a living core. It's capable of matter creation.
I know it doesn't have the magnetic signature of a planet.
Yeah. It doesn't seem to generate its own magnetic field, but as far as I know, I also thought it was a comet before, but from the latest findings, I would be more inclined to believe that it is a living planet. It has a living core and it's capable of matter creation, just like the sun and the Earth.
Well, these are interesting.
I mean, I'm still. This is like my newest discoveries, but that was my conclusion today when I looked at Venus again.
Well, I know I have my telescope and I look at it very often in these mornings here in Colorado. It's a fascinating view. It's very bright. Like Jupiter. Jupiter last summer was just spectacular. First time I can remember seeing at least a dozen of the moons around Jupiter, and that's another thing.
Yeah.
Well,
the moons.
When I went back and looked at a textbook in 1965, the textbook that was taught in 11th grade astronomy said that Jupiter had 9 moons. That's what it said. And today, the count is over now. I think it's reached 98.
Yes.
So obviously, there is rapid changes taking place within the solar system.
Yeah.
And it wouldn't surprise me that our scientists, they don't have all the answers. And so when I hear your theories, I have to say, listen, modern science is being proven wrong every day. They're going to have to rewrite the science books.
Wayne, they don't want to hide. They don't want to do that. So
I know.
As people become aware of certain things, they start putting out more information, but it's not usually the real information either. It's just a little closer to the truth, but it still diverts you away from the truth. That's what I think, because the last thing they want is for people to realize that what's happening to our planet started with the Great Flood. It never stopped, and it's now getting worse. That our solar system is full of new objects.
Well,
It's full of debris, and this debris is affecting our planet.
Well, I mean, I can remember again when I was in school, this was back in the late 60s and early 70s, we didn't have Ceres, we didn't have Cirrus, we didn't have, now I think the latest count, we have nearly 8, 9 new exoplanets that have come in. Yeah, so that tells me that our solar system is, I think, changing much more dramatically than what the scientists are wanting to say.
Yeah, I think actually the scientists, the mainstream scientists, are being kept in the dark about what's really going on. Because, I mean, I went through the training myself. And it's only when I started teaching that I started thinking deeper about what I was teaching and what it meant. And I realized that certain things were not making sense.
Mm-hmm.
It was then that I realized, but you see, when you're a physicist and you think, but I understood this as a student, what's wrong with me now? Do I have to go and restudy this? That's what you think first. But then I realized, as I went on, I thought, but it doesn't make sense. I'm trying to explain it. So I have to have a deeper understanding because I'm trying to teach it. And I just couldn't make sense of it properly. It wasn't logical. It didn't hold together. And that's what you look for when there are problems with a theory. Because the whole of physics should form a holistic picture that makes sense. And that
science doesn't do that.
Exactly. And they try to
Aren't they still looking for the unified theory?
Well, basically, model? I have found it.
The unified theory?
Yes. That's what my theory on gravity is. It's unified field theory because it unifies the strong force, gravity, and electromagnetism.
No, you know, this is Nobel, prize-winning type thing.
Yeah, I mean, that was my greatest discovery, was to discover that these objects are like protons in the nucleus. And they create matter, and they have a positive electric field, and that's why they don't collide. They produce a very strong electric field, which, even though they've lost their energy, it has not declined. That's why they cannot collide. And the same thing happens with protons in the nucleus. As they come closer, the force gets extremely strong. But if they get just a little bit too close, then the force becomes extremely strong and repulsive. So they can never collide. So gravity and the strong force are one and the same thing.
Well, it seems to me, Dr. Albers, as I see this going forward, is that science is being rewritten.
Oh, yeah.
I mean, you know, everything from the disqualification and disproving dark matter, dark energy, can't be found, can't be measured, can't be seen anywhere. Yet it's elusive, as, you know, science is trying to still say, well, what keeps the cohesion of the universe? There's not enough gravity to compensate for the mass.
Yeah, but you see, the problem with that is they will not let go of the Big Bang model and the idea that redshift tells you how far objects are. Mm-hmm. And it doesn't. Halton R proved, well, you don't prove anything, but he showed over and over again that redshift is intrinsic. It's to do with the age of the matter, which is created galaxies create matter. And I found that stars and planets also create matter. They're white holes all over the place instead of black holes. And what happens is because they overestimate the distance of objects. So if you have a galaxy that is much closer than the redshift distance that they would calculate for it, so it's a lot closer, but they think it's a lot further away. So it seems to be much brighter than it should be. So what does that mean to them? Because brightness and mass are associated. So a brighter galaxy would have a higher mass. But now they think they have a galaxy that's very far away, but it's very bright because it's not actually that far away. And therefore, they now think they have this galaxy that has a huge mass. So they overestimate the mass of galaxies that way. And that's why they then have a problem. Oh, gravity. There's not enough gravity.
So are you saying that the universe is smaller?
Yeah, well, a lot of the galaxies are a lot closer than astronomers and astrophysicists think, because they think that just because they have a high redshift, it means they're at the edge of the universe. And it's not like that. It just means that they newer matter.
Okay.
And that's why quasars have a high redshift, because they condense from newly created matter. And the matter that stellar cores create is always liquid. It's magma. They all create liquid magma, including galaxies. And Halton Arp said that in his book, Seeing Red, that it was a fluid that was ejected by the galaxies and that then condensed into quasars. And now I discover the Earth creates matter in the form of liquid plasma. We call it magma.
Wait a minute. You're saying magma is plasma?
Yeah. It's positively charged plasma created by the core of a planetary object or star or a galaxy.
Okay, I'm trying to grasp that magma. I mean, we know that is, liquid rock. I mean, it's what we see, but so I guess that then it would have to be redefined what plasma is, because I thought plasma is more of an electrical discharge but magma is, molten rock.
Yes, but it's positively charged because the core of the Earth is positively charged. There are electrons missing from it. The electrons get pushed out by the gravitational force to the outer layers of the planet. So the interior of the planet is positively charged. The surface is neutral. The atmosphere, as you move further and further up, is negatively charged.
Okay.
So the interior of the Earth is positively charged. So what we have is we have a positively charged liquid plasma. And the chromosphere on the sun is the same thing. It's magma, except it has a higher energy. It has more gravitational potential in it. So it's of a higher energy, at a higher energy level, that magma that the Earth creates. And the magma that galaxies create, galactic nuclei create, will have an even higher energy inside that matter.
Well, I'm going to have to meditate on that one, because when I see plasma, Claudia, what I think about, I lived in Austin, Texas for a number of years and was fortunate when we still had a space fleet, when the space shuttle would literally come over Austin, Texas in its glide path into Cape Canaveral. And one of the things that was always spectacular seeing the space shuttle as it went across was the plasma trail that it left. I mean, it was quite fantastic. As the space shuttle would come over, the plasma was this brilliant blue-white. And of course, the space shuttle was traveling, 2.5 times the speed of sound. But then it would get into that beautiful golden glow that would last for 5, 6, 7 minutes. It was something else.
Yeah, but that in the atmosphere and above the atmosphere of the Earth, what you're going to get is negatively charged plasma. It's like the sun's corona.
Thank you, Junior. Much appreciated. Yeah, and I guess that's what, it would be for a good discussion next time, is to really get down into this, because, it's like everything else. I knew how to ride my bicycle, and then someone gave me a 10-speed racer, and I went, what do I do with this? I was doing just fine with one gear. Now you're giving me 10?
Yeah, I know.
What do I do now?
Yeah, I mean, it's been mind-boggling for me to find some of these things.
Mind-boggling for me.
But the thing is, when I first looked at stellar cores, right at the beginning, I thought to myself, but they look like they're behaving like protons in the nucleus. And then I go through all these months of thinking about what they're actually doing, and I can actually show to myself, and using the theories that I came up with, that they are like protons. I call them super protons because they're not microscopic protons, the particle in the nucleus. They are astronomical objects behaving like protons.
See, and that's what I guess I'm going to have to think on. And, I'd love to get into maybe next week in this, because when I think of the galaxy, the poster behind me, that's the galactic core.
Mm-hmm.
When we think of micro and macro, that when we look at laws for the quantum, that the laws would then seemingly apply for the exponential. In other words, if we see the same activity of electrons, protons, we would then begin to see that in large mass, such as, galactic matter, these globules that we see behind us, which remind me of very much when I would look at an electron, a proton.
Yeah. And it's absolutely like that. The laws of the universe apply at all levels, and everything seems to be working the same way. But you have a planet that is positive on the inside and negative on the outside, just like an atom.
Yeah.
It's amazing.
Well, that's why I so appreciate you, because it allows for expansion of thought. So often, Claudia, that we see people that their perceptions are limited by boundaries. And if you have a thought, an idea, a hypothesis, an opinion that goes outside of that, they can't handle that. Well, they say, well, that's preposterous. It's impossible. But we have found so often that that's exactly how new science is discovered.
Yeah, I think so. I had to start thinking outside of what I've been trained to think, because I couldn't make sense of it.
Yeah.
And so far, I'm still discovering new things about the universe, and it's all through thinking logically and using whatever observations I have. I look for data everywhere, including the Bible. I mean, I looked at the Bible to see what it said about the flood. And I worked out a lot of things from that, because, sometimes you have to look at whatever historical record you have. And I think the Bible has a good historical record of the flood. It's not much, but we know it rained for 40 days and 40 nights.
I know of some better ones, but, but that's all right. And let me just say, as we wrap this up here for the year, you see, my dad was a NASA engineer. And in Houston, Texas, there was a boy who was born with I wouldn't call it, it was a genetic defect. He had no immunity. And they
Mm.
made a movie about him. John
Mhm.
Travolta played the role called the Bubble Boy.
Oh, yes.
And the thing that it was told to NASA, where my dad was at, that the child couldn't get outside the environment.
Hmm.
And they said it was impossible. But you see, my dad looked at things a little differently. And he came back, and what he proposed to the team was considered to be outrageous, unworkable, infeasible, asinine. But yet, in the end, it worked. And what my dad did was that he re-engineered a Yazoo bush mower and
Mm.
made that a platform that had a recycling air unit on it that allowed that child to then be put into an artificial movable environment. So my point being to all of this, to all those who sometimes write the very crass messages, is that when you write such things, it shows how small-minded you are, and you would be the one who would be the failure. If I had you on my team, I'd fire you because you see, you are not a critical thinker. You are not a free thinker. You are imprisoned by your concepts, your bigotry, and your intellectual stymianism. So, having said that, Claudia, 2019, what do you see evolving as? Because I obviously 2018 was a dramatic year for all of us in growth. Where do you see 2019?
You know what? When I see people getting very confused,
Mm,
um, there's a lot of confusion going on, because there are so many ideas. I think that's one of the things they are doing is they put out information, but all it does is make things confusing or too much false information.
yep.
And so, we have to be careful that, well, I always think, does this make sense? Is this logical? You have to connect the new information to the old information. You cannot just forget about what you discovered this year and suddenly decide, no, it's all wrong. And now,
Throw it out, right?
no, I mean, it
In fact, can I
makes
say something,
sense up to
Claudia? When you said that, our granddaughter was here over the holidays, and Lynn was giving her a bath, and we both had the same thought at the same time. That old axiom: you don't throw the baby out with the
now.
bathwater.
Yes.
Folks, we still got the baby. So,
Yeah, I mean, I haven't thrown away the old theories. I'm still using Newton's law of universal gravitation. I just say that the gravitational constant is not constant anymore. I still use Kepler's laws where I can apply them. I haven't forgotten what I've been taught. I just realize the limits of where they can be applied and where they cannot.
and can we say this about whether it's Newtonian laws, physics theories, whether it's Kepler, whoever we begin to think about, Freeman, I can go on with the others. But here's my point. That does not imply that that is fact. It's carved in stone. Those were observations based upon the observation of the scientists that brought these all. I still say I don't think Newton quite had it right. I mean, I don't think gravity is the primer.
Well, Kepler's laws are based on observation.
Correct.
So he basically used observations of the motion of the planets, the position of the planets, done by Tycho Brahe, who was the last naked eye astronomer, made very accurate observations. So there's nothing wrong with what Kepler did. He used the observations to figure out the mathematical relationships for the orbits of the planets.
Yep.
And then Newton came along and showed that Kepler's laws came from this one equation, which is law of gravitation. It's basically the same as Kepler's laws. So Newton's law, there's nothing wrong with it, but Newton never explained what was gravity. It's just a mathematical formula that allows you to calculate where a planet will be given this mass and this radial, its semi-major axis, basically. It's basically the same as Kepler's laws. It's not very much different. So it's just a mathematical format it's a transcription of where the planets were at which time into one mathematical formula. So there's nothing wrong with it. The only thing that I found out that's not right is that the constant that to Newton was a constant because he was observing planets that all had about the same energy connection to the sun. They were living stars. They were not energy depleted. So he didn't know about planet X. Then it had come in already, was already affecting the Earth, but he didn't know about it. It had been hidden from the Earth's population for thousands and thousands of years.
Well, I think, as you said, Newton never did describe gravity, never defined it. Claudia, we've got to wrap it up. I have another thing to go. It's been a great 2018. I'm looking forward to 2019.
Yes, I'm sure we'll do a lot more work.
Well, yeah, as each year, as we're fortunate enough to progress into the next one, it's the accumulation of knowledge and thought. And that's what keeps us agile. It's what keeps us flexible in our minds and our thinking.
Oh, yes.
Yeah.
Yep.
Well, you know what? The show just has grown in popularity. And I just thank you, Claudia, for the friendship and the companionship as we continue to look at things and with the balance of science and philosophy. And I'm looking forward to 2019.
Yes, thank you. Yeah, me too. And thank you for having me on the show. And
thank you. The honor is
and I'm
mine.
sure Scott will keep on making lots of discoveries. He's always
looking forward to having him
he's
back
made
on.
some new ones. Again, I'm sure. Yeah, he sent me some pictures today of a new one. So
I think we're going to see a whole lot more of that. I think we are. All right, my dear. Well, thank you. I just want to thank all the moderators. Thank all of you. Thank every one of you. Have those of you who are already in the new year, Happy New Year to you. Those of us who are still yet to experience, it shows you time travel is real, Claudia.
Yes.
So, Claudia, thank you, my dear. Honored.
Thank you, Wayne.
And folks, we will see you next week for the Physicist and Philosopher. Namaste to all of you. Thank you, Claudia. Blessing to you for the new year, my dear.
Thank you.
All
you
right,
too.
everyone. Bye-bye.
Bye.